Did you know that Niels Henrik Abel, a mathematical genius, was born into poverty in Norway in 1802? Indeed, Abel's life story is as fascinating as his groundbreaking mathematical theories. Born into a poor family in a small Norwegian town, Abel's brilliance shone through from an early age. His passion for mathematics was sparked by his first mathematics teacher, who recognized Abel's potential and encouraged him to pursue his interest. Despite his family's financial struggles, Abel was determined to further his education. He entered the University of Christiania at the tender age of 15, where he began his journey into the world of complex equations and abstract theories. His dedication to his studies was unwavering, even as he grappled with the harsh realities of his socio-economic status. Abel's life was not an easy one, fraught with financial hardships and personal tragedies, yet his love for mathematics remained steadfast. Despite his humble beginnings, Abel's love for mathematics led him to make remarkable contributions to the field. Abel's theorem, ever heard of it? It's a cornerstone in the world of algebra, named after Niels Henrik Abel, a Norwegian mathematician who lived in the early 19th century. Abel's theorem revolves around polynomial equations, those expressions you might remember from your algebra classes that combine variables, coefficients, and exponents. Now, what's so special about this theorem? Well, Abel was the first to prove that general polynomial equations of the fifth degree or higher cannot be solved by radicals. In simple terms, you can't find the roots of these equations using the usual mathematical operations and root extractions. This was a significant departure from the existing understanding at the time, and a solution to a problem that had puzzled mathematicians for centuries. Abel's theorem not only revolutionized our understanding of polynomial equations, but it also laid the groundwork for further developments in abstract algebra, notably group theory. Abel's theorem, with its groundbreaking insights, forever changed the landscape of algebra. Abel didn't just stop at algebra, he ventured into number theory too. He turned his attention to elliptic functions, which are functions defined by equations of a certain form. These equations encompass the structure of elliptic curves, a topic of great interest in number theory. Abel's work in this area was revolutionary. He proved that elliptic functions could be expressed as infinite series, a concept that was groundbreaking at the time. This discovery opened up new avenues in number theory, providing a fresh perspective on the relationships between numbers and functions. Furthermore, Abel's work on elliptic functions laid the groundwork for modern algebraic geometry. He introduced the concept of abelian functions, which are now a cornerstone of the field. His research demonstrated the intrinsic connections between algebra and geometry, showing that numbers and shapes are more intertwined than we might initially think. His work in number theory further solidified his place in the annals of mathematical history. In honor of Abel's contributions, we have the Abel Prize. This prestigious recognition, established by the Norwegian government in 2001, is often referred to as the Nobel Prize of Mathematics. It was named after Niels Henrik Abel to honor his remarkable contributions to the field of mathematics. The Abel Prize is awarded annually to one or more outstanding mathematicians, acknowledging their innovative research and breakthroughs. Much like Abel's groundbreaking work in his time, the recipients of this esteemed award have included such luminaries as Sir Andrew Wiles, who famously proved Fermat's last theorem, and Karen Uhlenbeck, the first woman to receive the Abel Prize, known for her work in geometric analysis and gauge theory. These exceptional individuals exemplify the spirit of Abel's work, pushing the boundaries of mathematical understanding and opening up new horizons. The Abel Prize, in honoring excellence in mathematics, carries forward Abel's legacy. Abel's work continues to resonate in modern algebra. His profound ideas have shaped the field in ways that are still evident today. One of the most significant concepts that Abel introduced was the idea of an abelian group. This concept, named in his honor, is a cornerstone of modern algebra. It's a group in which the operation is commutative, meaning the order in which the elements are combined doesn't affect the outcome. Furthermore, Abel's work on polynomial equations laid the groundwork for Galois theory, a branch of algebra that has far-reaching implications in fields as diverse as cryptography and quantum mechanics. His pioneering research on elliptic functions also led to the development of complex analysis, another fundamental component of modern algebra. In essence, Abel's contributions have not only deepened our understanding of algebra but also expanded its reach. Abel's influence in algebra is indelible and continues to inspire mathematicians today. Abel's work also intersected with another great mathematician, Evariste Galois. While both Abel and Galois were pioneers in their own rights, Their theories in algebra often overlapped, creating a confluence of ideas that significantly shaped modern algebra. Abel's groundbreaking work on elliptic functions and Galois' innovative theory, now known as Galois theory, both delved into the profound complexities of algebraic equations. These two brilliant minds never directly collaborated, but their parallel paths led to significant intersections in their work. Abel's theorem, for instance, provided a foundation for Galois' exploration of the solvability of algebraic equations by radicals. The synergy of their ideas, their shared passion for untangling the intricate webs of algebra, created a ripple effect that is still felt in the field today. Their individual contributions were substantial, but when viewed together, they formed a tapestry of ideas that revolutionized our understanding of algebra. Their combined efforts further pushed the boundaries of algebra. Abel's influence extends to how we write mathematics as well. Niels Henrik Abel's contributions to mathematical notation and symbolism are a significant part of his legacy. His work has helped streamline mathematical communication, making complex ideas more accessible and easier to understand. Abel's notation for mathematical functions, for instance, is a simple but powerful tool. By representing functions as letters followed by parentheses enclosing the variable, Abel introduced a notation that is now standard in mathematics. This seemingly simple change made mathematical expressions easier to read and write, promoting clarity and reducing errors. Moreover, Abel's notation for the integral, a fundamental concept in calculus, is another example of his lasting impact. By using a specific symbol to represent this operation, Abel streamlined mathematical language and made it significantly more efficient. So, as we delve into equations or solve integrals, we're using Abel's language whether we realize it or not. Abel's notations, still widely used, are a testament to his enduring impact. Abel's life was tragically cut short, leaving some of his work unfinished. At the tender age of 26, Niels Henrik Abel's life was abruptly halted by tuberculosis. His early departure from this world left a gap in his mathematical journey, leaving us to wonder about the unexplored avenues of his genius. Despite his short life, Abel managed to make groundbreaking contributions in several areas of mathematics. However, some of his research remained incomplete due to his untimely death. There were tantalizing hints of further discoveries in his notes, suggesting potential directions his work could have taken. These included his initial investigations into what we now call abelian functions, a concept that would later form a significant part of algebraic geometry. His unfinished work, like a puzzle with missing pieces, continues to pique the interest of mathematicians around the world. They delve into his notes, striving to unlock the secrets they hold and carry forward Abel's legacy. Despite his untimely death, Abel's unfinished work continues to intrigue mathematicians. Abel's life may have been short, but his legacy in mathematics is everlasting. The story of Niels Henrik Abel is a testament to the enduring power of intellectual curiosity and indomitable spirit. His contributions to algebra, number theory, and mathematical notation continue to be the building blocks of modern mathematics. From the introduction of what we now call abelian groups to his pioneering work on elliptic functions, Abel transformed the landscape of algebra. His theorem, which proved the impossibility of solving the general quintic equation in radicals, remains a cornerstone in the field. In the realm of number theory, Abel's research on elliptic functions marked a significant shift. His work provided the groundwork for future mathematicians and is still widely studied today. Moreover, Abel's influence extended to the realm of mathematical notation. His innovative use of symbols and notation streamlined mathematical language, making complex concepts more accessible. But Abel's influence doesn't stop at his original contributions. His collaboration with Evariste Galois birthed a new branch of algebra, Galois theory, which has been instrumental in solving equations that had puzzled mathematicians for centuries. The Abel Prize, named in his honor, recognizes outstanding contributions in the field of mathematics. It's a testament to the respect Abel commands in the mathematical community and the lasting impact of his work. Despite his untimely death at the tender age of 26, Abel's work remained unfinished. Yet, his brief life was filled with monumental achievements that continue to resonate in the world of mathematics. In conclusion, Abel's legacy is a testament to the power of the human intellect. His contributions have stood the test of time and continue to shape the world of mathematics. His life and work serve as a beacon of inspiration for mathematicians, a reminder of what can be achieved with dedication, curiosity, and a bit of genius. Niels Henrik Abel, a name written in the stars of the mathematical universe, continues to inspire the mathematicians of today and will do so for generations to come.